Assalamualaikum and good day everyone. I am Helmi Husaini.
Power, including 60
on the dangers of these views,
and a target to replace 600,000 gas boilers a year by 2020.
Ladies and gentlemen, boys and girls, we all are familiar with the term of biofuel. But do you know that not all biofuel are actually sustainable? Hence, I will present to you a review on biodiesel production from Macroalgae Caulerpa racemosa through Transesterification Process. Industrial Revolution had caused the increasing of the world fuel consumption. As per reported by Gune et al. 2019, there are several issues possessed by the usage of the traditional fuel that include the health issue, economic issue, as well as the environmental issue. Thus, scientists divert their interest to biodiesel as an alternative fuel as per reported by EIA 2020. Algae were considered as one of the promising feedstocks out of 365 identified feedstock for biodiesel production due to its abundance and no fuel versus food issues. In Malaysia, there are 386 taxa of marine algae, and Caulerpa racemosa was reported to be a suitable feedstock for biodiesel production due to its abundance and more composition of carbohydrate, protein and lipid as to compare to other species of marine algae in Malaysia, as per reported by Latif et al. 2019. First thing first, there are several problems related to traditional fuel that have been identified. Thus, there is a need to find the alternative for petroleum-based fuel. Secondly, Caulerpa racemosa has not been widely utilized. In most studies regarding to Caulerpa racemosa, the study only focused on the anti-proliferative, antibacterial, and anti-neoplastic properties. Thirdly, the study of optimization for transesterification process for Caulerpa racemosa is insufficient. In terms of the significance of the study, first thing first, the advantages of the marine algae to be the feedstock of biodiesel production will be further analyzed. Secondly, the underutilized Caulerpa racemosa that is abundant in number can be utilized in terms of its application to produce biodiesel. Thirdly, the variation in optimal condition for transesterification process of Caulerpa racemosa will be further determined. The objective of these studies include three things. The first one, to find and suggest the best alternative sources in producing renewable energy. Secondly, to identify the potential of Caulerpa racemosa as feedstock of renewable fuel production. And thirdly, to determine the optimum condition for transesterification process of marine algae to produce renewable fuel. Now, let's move on to the second part of the study, which is the literature review. In this literature review, there are 5 key aspects that will be further discussed. The first key aspect is about the diesel fuel. Fuel could be divided into two, the primary fuel and secondary fuel, as reported by Hanani et al. 2020. Pereira 2020 illustrate that environmental issues of traditional fuel include the release of various polluting gases into the environment. Police Canova 2020, on the other hand, shows that health repercussions such as cancer, heart and lung diseases are the effect of using traditional fuel. While Gune et al. 2019 shows that in terms of the economic issues, the price of the diesel increased due to the increment in the demand. The second key aspect in this literature review is about the biodiesel. Hazard et al. Reported two things. The first one, biodiesel fuel comprised of long-chain monoalkyl fatty acid esters extracted from edible and non-edible feedstock, while the usage of biodiesel instead of fossil fuel will help to lower down the greenhouse gas emission. Ho et al. On the other hand, reported that biodiesel has several advantages over conventional diesel in terms of its toxic-free content, sulfur-free content, while offering a better lubrication. As per reported by Ambat et al. In year 2018, the feedstock selection affect the cost of produced biodiesel, including its yield, composition, and purity. Gaurav et al. In year 2017, on the other hand, reported that macroalgae and microalgae are favored over other terrestrial plants in producing biodiesel. Ong et al. In year 2019, on the other hand, reported that Malaysia has a huge resource of macroalgae, but the usage of this algae is still underutilized. The next important key finding in these studies is about the Caulerpa racemosa. Hamila et al. In 2016 shows that all part of the macroalgae, except the rhizoids, has the potential to be used in producing the biodiesel. Bouillon et al. In 2016 shows that Caulerpa racemosa consists of 19.72% of protein, crude lipid of 7.65% and 48.97% of the carbohydrate. While Latif et al. In 2019 shows that Caulerpa racemosa is abundant in number and can be found in East Coast Peninsula Malaysia, West Coast Peninsula Malaysia, and also Sabah. The last key important features in the literature review is about the method of biodiesel production. As per postulated in the diagram is the transesterification. The protocol begins by the extraction of the algal oil from Caulerpa racemosa. Then, this algal oil will be reacted with methanol and potassium hydroxide throughout the transesterification process. As the result, as you can see, the bottom layer consists of the glycerin, while the upper layer consists of the methyl ester or the crude biodiesel. The glycerin, on the other hand, will be refined and disposed for further use. The methyl ester will undergo two processes. First, it will be refined to produce biodiesel, and secondly, it will undergo the recovery process. Shamila et al. 2016 reported that different macroalgae species has different optimum condition for transesterification process in biodiesel production. Vera Pongpipat and Suksomanat 2019 reported that biodiesel from Caulerpa racemosa was best produced with 1.5% catalyst concentration. In this case, KOH is used at 60 degrees Celsius, and the reaction was completed within 8 hours with 1:15 oil to methanol ratio. As you can see, is the fuel property between the algal biodiesel and ASTM standard as per reported by Kamaka et al. 2018. As you can see, there are 10 fuel property that has been tasted to the produced biodiesel, and we can see that the algal biodiesel produced comply with the all ASTM standard. So the three major conclusions that can be made. The first one, environmental, health and economic issue had diverted scientists' interest to renewable fuel, and marine algae was considered as one of the suitable feedstock for biodiesel production. Secondly, Caulerpa racemosa is essential for biodiesel production. Thirdly, it is reported that biodiesel from Caulerpa racemosa was best produced with 1.5% catalyst concentration. In this case, KOH is used at 60 degrees Celsius, and the reaction was completed within 8 hours with 1:15 oil to methanol ratio. As a recommendation, the genetic engineering technique should be deployed in the fuel making process. By using this technique, scientists could retrieve the important component in the renewable fuel production, particularly from the marine algae. The deployment of this technique in fuel making processes could have two advantages. The first one, renewable feedstock can be processed in bulk, and second one, the price of the biodiesel produced could be reduced. Well, that's it, the end of the presentation. I would like to express my utmost gratitude to my fellow supervisor Puan Atika Husna binti Ahmad Nasir and to my co-supervisor Puan Asnayanti binti Ani for their endless support and commitment. Well, to my examiner, happy watching this video and happy asking. That's it everyone. Thank you very much.